Alright folks, this video is going to cover when you are asked about intervals of increasing, decreasing, or max-min, or critical numbers. Okay, and then also is going to talk about higher order derivatives. Okay, so first up, this is number 3, part C, okay, the tougher equation here. And what we're going to do when we see increasing, decreasing, maximize, minimize, things like that, those are words that indicate you need to find the first derivative. And generally we're setting that equal to 0 to solve for our critical numbers. Okay, so when we look here, a lot of times it's going to be helpful for you to substitute. And instead of that square root, if you're not used to the pattern, okay, when you see this x squared plus 1, it's really x squared plus 1 all to the power of 1/2, and then we can apply our power rule. Okay, so our derivative would look like that 1/2 coming to the front, and then we're going to subtract 1, so that would be x squared plus 1 to the negative 1/2 power. But because there's an x in here with a power, we've got to use the chain rule, and then we're multiplying by the derivative of this thing. So using our power rule again, that 2 comes down, so that's the 2x, and 2 minus 1 is a power of 1. The constant goes away, remember, and then we're going to rewrite this or simplify this before we go set it equal to 0. So this negative power means that whole thing goes down below, so this would be 2x on the top, okay, because of this part. Then we have the 2 on the bottom of the fraction with this whole piece, and you can put it back in your root or leave it as your power, it doesn't matter, but that's our second plus 1. And then those 2's cancel out. So now we'll take this derivative and we'll set it equal to 0. So I'm just going to substitute 0 right there. We've got x over square root of that x squared plus 1, and we have to solve for our variable. Anytime you have a fraction equal to 0, you're going to multiply the denominator over, and hopefully you have comfortable feelings about when you see that denominator, 0 times anything, it goes away, that we really only have to focus on the numerator. So after that stuff cancels, we have 0 over here, that's gone, and we're left with just x, and that is our critical number. Okay, so from here, that critical number is going to give either a maximum or a minimum, and we're going to talk about increasing and decreasing to figure out which one. Okay, so this is just using the first derivative test. So what you're going to do is you're going to make a little number line, and you're going to put that critical number, if there's more than one, then you put all of them on your number line. And what I like to do is use a table of values to simplify this, because you really don't have to do this by hand. Okay, so our derivative was this. What you'll do is put that in your y equals of your calculator into your table. Okay, so I've already inputted that x divided by that square root, and then you just go to your table. So second table, we want to look at what's happening on the left-hand side as you go towards negative infinity, and what happens on the right-hand side as you go towards positive infinity. We're just looking about the sign. That's the only thing that matters. So on the back side of 0, all of those are negative values. So we're just going to jot down a negative. Okay, on the front side of 0, there are positive values. So that tells you here we are decreasing, and here we are increasing. And those are our intervals from negative infinity to 0, decreasing, and from 0 to infinity, it's increasing. So if we start out, we're thinking about a graph, and this is not the graph we're working with, but I just want to talk about shape here. This would be a maximum, this would be a minimum, a maximum, and a minimum. It's all these turning points, and it's where it's turning from increasing to decreasing as we look from left to right, or decreasing to increasing. So here's what's happening on ours. From left to right means low to high. We're decreasing first. If we're decreasing first, it would have to go down first, hit the point, and then it says it goes to increasing, which means visually we're at a minimum value. So this is at a minimum, and now we just have to find the point it goes with. Okay, because this is a value on the original graph, we're going to plug this 0 in the original equation. Okay, so I'm going to go back up here and just do f of 0 and plug that in. So 0 squared plus 1, that's just the square root of 1, which is 1. So the ordered pair, that's the minimum, is 0, 1, and that is it. Okay, this process, your derivative is going to look different for the different types of equations you could see, but the process for finding critical numbers, using your number line, determining max or min, that's always going to look the same. Please use your table to help you for those. Okay, second one this is going to cover is higher order derivatives. So we've talked about first derivative. This next one asks for the second derivative, and it's noted by this double marks here. When we're talking about word problems, this would relate to concavity, okay, on a graph. It would talk about inflection point or point of diminishing returns. Okay, those are items that go with the second derivative. So what we're going to do is just lay this out, okay, rewriting anything if we need to. In this case, it's already pretty good to go, meaning if you've got a square root that you want to change power to, or if you've got weird parentheses that you could simplify, that kind of thing. This one's good to go. So now we're going to find the first derivative, just using our rules here. Okay, so rules with E, remember, with an exponential function, you're going to multiply the original equation by the derivative of your power. So our original part was the 5e to the x squared, and now we're multiplying it by the derivative of our power. So our power was x squared. Using our power rule, we would do 2x, and then that 2 decreases to 1. So that's the derivative of the first part. And then our natural log, remember, it's just 1 over the thing inside. Okay, so 1 over x multiplied by the derivative of the inside if we have it. We don't have to worry about it here. Okay, that's our first derivative. Before you do the second derivative, you want to simplify. That's going to make your life easier. Okay, so here we want to recall this first derivative and just put our numbers together here. So 5 and 2 makes 10. I like putting that x first and then your e. That way we can see our exponential still. And this 1 over x is fine. Okay, so now here's something super important. This times didn't go away. This x is a function where this e to the x is a function as well. If x is in two different places, y'all, this is a product rule. Okay, so we have to recognize this is 10x times this exponential. And if it's a product rule, we got to split it up. So our second derivative here, the derivative of the first part is just 10 times the second part, e to the x squared. Then plus, we flip-flop those. So now I'm going to do the derivative of the second part. So that's the e to the x squared, remember chain rule, multiplied by the derivative of that. So that'd be 2x. Okay, then times the original first part. So that's the 10x. Alright, this all goes with the first part. Now we go to the second part. 1 over x. This is another one where if you rewrite it, it may be helpful. Okay, so this is the same thing as x to the negative 1 power, moving it up. So then we multiply the negative 1. Okay, so I usually won't write this one, but I will for now. Negative 1. And then x, negative 1 minus 1 is negative 2, and this means x squared goes below. So just some formatting to finish up here. This 10 e to the x squared is fine, but let's talk about this. Numbers 2 times 10, so we can call that 20. X times x is x squared, and then I like to put that exponential at the end. Here, we already talked about that 1 goes on top, but then that x squared will go to the bottom, and that is all.